Recording has started. All right, we are recording on, what is it, Wednesday, September 2nd, 2015, the WSSB second period statistics class, just for you and me. All right, homework. Let's go over homework. So you had to find
10 random people.
10 random people and ask them
For their age.
10 random people, ask them their age, okay, and then create a data set, and then find the central tendencies, the range, and if you think there's an outlier. All right, so what were your 10 ages?
2 12s.
2 12s.
3 14-year-olds.
3 14-year-olds.
1 16-year-old.
1 16-year-old.
2 17-year-olds.
2 17-year-olds.
1 27.
1 27.
And your age.
And 48, if we round up. All right, so I have 12, 12, 14, 14, 14, 16, 17, 17, 27, 48.
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and I noticed you detailed them for me in order. Did you collect them in that order?
No, this is the order.
Okay, so they were very random and you had to put them in order.
Yeah,
right?
I did here.
Okay, excellent strategy. Okay, so what did you find first?
Well, I did the outlier.
You thought there was an outlier, and what outlier do you think there is?
48.
48, so that's our prediction on an outlier. We'll find out later if that prediction is true, because there's some math we can do around that. Okay, then what?
Did the mean.
The mean. All right, how'd you figure out the mean?
So I added these all up.
Add them all up.
And divide by how many there is, which is, there's 10.
Okay. All right, so when we add 12 plus 12 plus 14 plus 14 plus 14 plus 16 plus 17 plus 17 plus 27 plus 48, and we divide by, I'm writing it out, we divide by 10, what'd you end up with?
19.1.
19.1 is the mean or average age. Okay, then what'd you find?
The range.
The range, okay.
Is 36.
Range is 36. How did you find the range?
I took the youngest person and the oldest person and subtracted the youngest person from the oldest person.
Okay. 48 minus 12 is 36. That's correct. Then what did you find?
The mode.
The mode.
Which was 14.
And how did you discover the mode was 14?
Because it was the number that was repeated the most.
Okay, good. And why did you not pick 12 and 17?
Because 14 had 3.
Excellent. All right. And then?
The median
Was
15.
Was 15. So what is, that's correct. How did you find that? Because it's an even number of digits, so there isn't really a middle number.
Because so I put them in order. And I went and counted. And 14 and 16 were both
in the middle, 14 and 16, okay.
And then right in between that's 15.
Right in between that's 15. So the middle of 14 and 16 is 15. Or you add 14 and 16 and get 30, divide by 2 is 15. But we know in our head, right?
Yeah.
Okay. So that is right. The median is 15. And then you speculate or you think the outlier is 48. So that's good. Nicely done.
Cool.
Okay. Now, 5 points that was worth, I think, right?
Yes.
I'm going to remember to record that. If we take the same data set, so we can write it out again.
Okay.
Right.
Sharpie.
Okay. I'm just writing it out on the board here. 12, 12, 14, 14, 14, 16, 17, 17, 27, 48. Okay. And you know that the median was at 15, right? Okay. Now, in a data set, there's a lower, what's called a lower quartile and an upper quartile. Have you ever heard of that before?
I've heard of it, but I do not know what it means.
Okay. So Oh, rats, I lost my book. Okay. The
Is this
lower
it?
quartile, not that one. I mean, that's the new one, but there's one that just talks about lower quartile, upper quartile. So basically what it means is the lower half of our data and the upper half of our data.
So basically, where it splits in half.
Yeah. So if you have your middle,
Mm-hmm.
and then where that splits in half, when you look to the left,
Is it where it splits?
that's your lower quartile.
Okay.
And if you look to the right, that's your upper quartile.
Is it where it splits in half, what, 15?
Yeah.
Or between?
So we have 12, 12, 14, 14, 14.
Which is the lower.
Yeah. And then the upper would be 16, 17, 17, 27, 48.
Yeah.
Okay. Now, within the lower quartile, there is a median. So if you wanted to make if you wanted to split it like with your pen or something, and just like, split off the upper and the lower to look at them. Yeah. When you look at just the lower quartile, you have 12, 12, 14, 14, 14, right? Does that make sense?
Yeah.
Okay. And when you look at the upper quartile, you have 16, 17, 17, 27, 48. Does that make sense?
Mm-hmm.
Okay. So if you look at just the lower quartile, you have a median of the lower quartile. What's the median of the lower quartile?
14?
14. Yeah.
So what do you put, like,
I would
low?
circle that number for now just to identify it. Okay. And when you look at the upper quartile, what do you have?
17.
17, right. 1, 2, 3, yep, 17. Okay. So those are important numbers, all right, we're going to talk about, because then we're going to get what's called the interquartile range. So think about the word range.
Okay.
What does that mean if you just had range?
The difference.
Right, the difference between the lowest number and the highest number, right? So an interquartile range would be the difference between
the lower quartile and the higher quartile?
Yeah, the median of the lower quartile and the higher quartile, right?
So that will be 3.
Yep. So the interquartile range, or the IQR, equals 3.
What's the abbreviation? IQR?
IQR, interquartile range. Now, with the interquartile range, we take that number and we multiply it by 1.5.
What's that do?
So it gives us a number that we're going to use for something. So 3 times 1.5. 3 times $1.50. 3 people have $1.50.
450?
450. 4.5. Good.
I think.
Okay. All right. So that's an important number, because what we're going to do is we're going to take that number and we're going to subtract it from our lowest number. So the 12. 12 minus 4.5.
7.5.
7.5. And we're going to add it. Oh, excuse me. I'm sorry. We have to take it and I totally biffed this. Let me remind myself what we have to do. So we have to take the interquartile.
Mm-hmm.
And let's see. Quartile 1, quartile 2, subtract and multiply them. Let's see, multiply or find the, okay, we subtracted them, found that it was 3, and then we multiply it by 1.5. Okay, then we take, so then we take the, I'm reviewing here. We subtract, from our quartiles. There we go. Okay, so we subtract it from 14. Sorry about that. So 14 was our lower quartile minus 4.5.
9.5.
9.5. There we go. And we add it to our upper quartile. 17 plus 4.5.
21.5.
21.5. Yeah. Okay, there we go. Sorry, I grabbed the lowest number and went, no, we're not supposed to do that because that would have always made it wrong. Okay, so recap. You find your lower quartile, your median of your lower range of your lower half of your data. Your median is called your lower quartile. You find your median of your upper half of your data is called your upper quartile. So that was 17. You take the lower quartile and the upper quartile and find the range. That's called the interquartile range, and that was 3 because we went, the difference between 14 and 17 is 3. We take that number and multiply it by 1.5 and we get 4.5. So 3 times 1.5 is 4.5. Then we subtract that 4.5, the interquartile, from our lower quartile, or quartile 1, and add it to our upper quartile to get two numbers, 9.5 and 21.5. Those two numbers help us determine if we have outliers.
Okay.
The 9.5, if any number in our data is below 9.5, it's an outlier. So is anything below 9.5?
No.
No. So 12 is fine. Is anything above 21.5?
There's 2.
There's 2 outliers. You're right. In your data set, you were correct to identify 48, but there's also 27 and 48. Isn't that interesting?
Yeah, it is.
Yeah. So
I have a question about like the quartile.
Mm-hmm.
Let's say you have 11 numbers.
Mm-hmm.
What do you do from that?
So you count that's a really great question. So you would have 11 numbers. So let's say let's just say we had 12, 12, 12, 14, 14, 14, 16, 17, 17, 27, and 48, right?
Uh-huh.
So if you came into the middle, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, you would have a 14 in the middle, right? You include that 14 with the lower half, and you include that 14 with the upper half.
So it's kind of like a yin.
Yes. Yeah. It overlaps.
Yeah, whatever.
So that median gets to be part of the lower half and part of the upper half.
Okay.
So then it creates 1, 2, 3, 4, 5, 6 numbers, right, in the upper half. Yeah. So then the middle is 2 numbers in the middle that you have to add together and find the middle. That makes sense? We'll do it. We'll practice that again. That's a really great question. But let's finish with this data set. So now that you know your outliers are 27 and 48, we could re-look at the data, kicking the outliers out and see what happens. All right? So now we're going to do the mean, median, mode, and range on just 12 through 17 and compare it. Okay?
Well, the range will stay the same.
The range is 12 to 17.
No, I meant
Yeah.
What's
On the new data. But let's really focus on the central tendencies.
the mode will stay the same.
The mode is still 14. Okay. So now we have 12, 12, 14, 14, 14, 16, 17, 17, right? Because we kicked our outliers out, and we're going to relook at it. We're going to let our readers know, let the research team know, whatever, whoever we're reporting this to, we let them know that we did have two outliers, 27 and 48. And with the outliers, our mean was 19.1, and our mode was 14, and our median was 15. But now we're going to recalculate without the outliers. So you still know your mode is 14, you're right.
Okay.
Okay. Yeah. Now what's your median?
Well, median's the middle.
Okay.
So it has to be in between 14s.
Yeah, so it is
14.5.
Nope. Between
14.
14 is just 14. Yeah.
Okay.
Okay. Yep. There's nothing between 14 and 14.
There's not a 15 there.
No.
It's just 14.
It's 14 and 14. So there's nothing between 14, just 14. Okay? All right, so the mode and the median are 14.
Range is 5.
The range would be 5 on this new data set. Now you would report both the ranges. You would say my range on my original data set was 36, but I had an outlier. So now on my new, kicking out my outliers, it's 5. Okay? All right, and then what is our mean?
So 12 plus 12 is 24. And 14 plus 14 is 28. So that becomes 52. And that'll be 66, 82, 93, 110.
10, 20, 30, 40, 50, 60, 70, 80, 82, 84, 88, 92, 96, 102, 109, 116.
That was close.
Is that what you got?
No, I got 110.
All right. Then we just also, it's advanced math now. We just do a calculator.
Divided by 8.
All right. $116 divided by 8.
Yes.
14.5.
I'm younger than I am.
All right. 14.5 is our mean. So when we look at our original calculations, the mean was 19.1. Now it's 14.5.
So it drops 5.
Yeah.
Or
4.6-ish.
yes, around there.
Those outliers were influencing our average age by almost 5 years.
Yeah.
But more of our students, 8 of our students, are actually closer. Like the 12-year-old is not close to 19.1, right?
But the 17-year-old is.
The 17-year-old was, but the 12-year-old is more closer to 14.5, as is the 17-year-old.
It's basically in the middle.
Right. It's more true, right? Because the 48-year-old isn't even close to 19.1 or 14.5, right? Okay. So you see, even the 27-year-old.
27-year-old's pushing it.
Yeah, and that's why when we did our calculations, it got considered an outlier compared to the rest of the data, right? The data was a little shifted to the right and a little bit older. The 27-year-old might have been counted, but because it's down here. Now, what is the mean in relationship to the mode and the median?
Can you repeat that?
What is the mean at 14.5 in relationship to the mode and the median?
All the same, basically.
It's closer, isn't it? Yeah, it's much more reflective of, oh, this is a pretty strong data,
Unlike this one that's
19 was much further away from a mode of 14 and a median of 15. Yeah, so that's interesting to consider. So definitely that outlier, that 48 outlier and that 27 outlier, it was influencing our data set. The 27 pulled the 48 kind of back a little bit, but not enough really to be representative. Because if you went walking around and said, I polled 10 people in school today and the average age is 19,
They think it's a college.
They would be like, what? And I'd be like, oh, well, I pull, and it's actually when I throw out my outliers, because I, ran into a couple staff members. So that's another thing that's starting to talk about your sample size or what you pulled. I just told you to go out and randomly poll people in the school, right?
Yeah.
And so you just asked anybody.
And the majority of our school is middle schoolers now.
Right. That's a good, yep. And so it should be, a
Lower.
younger, lower age, right? And then we threw our outliers out. Now, if we thought about our sample size and said, or our sample even, I'm going to go out and poll only students. We probably wouldn't have any outliers, would we?
Probably not.
Probably not. Yeah. So this helped us by kicking out the outliers because most of the people you talk to were students. And what are most of the people in the school? Students. So it should have been that, like you ran into. Now, if I said, go out and poll non-students, right? Staff or no students, you run into anybody, they can't be a student here, ask them their age, then we're going to get a different analysis of people that aren't students.
It could be anywhere from like 11 to 70.
Non-students?
Yeah.
Mm-hmm. Yeah, depending on who's there. So thinking about your sample, who you talk to, in that criteria. If you randomly were just talking to it, then you could say, well, I went around randomly and talked to people that were students. Now, if you wanted to know the average age of the entire world, the entire campus of WSSB, you would want to get an equal number of people that are students, right, in your sample, and an equal number of non-students, right, to kind of balance out your sample, because you want to get an overall average age for the whole campus, right? So you'd have to be thinking about, I've got to get a really good sample, or maybe a larger sample, maybe 10 people isn't going to work for me. I might have to quiz 20, right? We're going to talk about that when we enter into the statistics book, about really thinking about our sample size, who we're randomly getting information from, how reliable is that,
And they say an average of 2,000 red cars go on I-5 a day.
Mm-hmm. Right.
It could be just cars, it could be cars, trucks, and...
Right, exactly. You got to think about all those criteria. So we'll get into that later. But now back to, so you learned about how to find outliers. So when you have a data set, there's some basics that you can look at your data set. So yesterday we talked about, you have your range, right?
Yeah.
You have your mean,
Yep.
your median,
Yep.
your mode,
Mm-hmm.
then you have your lower quartile,
Your
upper quartile, interquartile range. Then you multiply that by 1.5, and you have to subtract it from lower quartile, add it to upper quartile, and then you figure out whether you have, on those numbers, do I have any outliers, right?
Yeah.
Okay. That's one of the basic things you can do to a data set, is to figure out all those basic information. Then what we do is we put it in graphical form in a box and whisker plot sometimes, which we'll learn how to do probably tomorrow. But let's practice this again on a data set. How's that sound? All right. So let me see if I can find a random data set in our book that looks interesting. It's not too
You can just look one up on the internet.
Crazy long. Just opening my book here. I want to be able to get a little bit of everything. So here's just a single number of TV sets in randomly selected households. Now they gave us 50, but let's not do this whole thing. Let's just do the
10.
First 10. How's that sound? 1, 2, 3, 4, 5, 6, 7, 8,
Or
9,
do you
10.
want to choose randomly 10 in there?
Oh, yeah, I like that. All right. 1, 2, 1, 2.
I see a pattern.
1, 3, 4, 2.
So this is number 8.
4, and 5. How's that sound? I just kind of launched my finger all over the data and pulled out those numbers. Okay, so the 50 data set had 1, 1, 1, 2, 6, 3, 3, 4, 2, 4, 3, 2, 1, 5, 3, it was all over the place. All right, so 1, 2, 1, 2, 1, 3, 4, 2, 4, 5. So what do we want to do first?
Put it in order.
Put it in order. All right. We'll learn how to do this also with a computer, but for now it's always good practice to do it by hand to understand what the computer is doing.
So we have 3 1s, 3 2s.
See what I have. I have 1, 2, 3, 3 2s. Yep.
1 3. 2 4s.
Yep.
1 5.
Yep.
Alright, so do you want to do it before we see if there's any outliers?
Actually, it's good practice to find your mean after you found outliers. So you're right. So find the median, find the lower quartile, find the upper quartile, make sure we don't have any outliers. So good job. So what's our median?
It'll be 2.
Yep. Okay. So our median is 2. So we include 1, 2, 3, 4, 5. Yep, we have the 5 on one side, and then we have 5 numbers on the other side. That's our.
So it's gonna be right between the 2 and the 3.
So if we went, hold on. So 1, 2, 3, 4, 5. No, it's right between the 2 and the 2.
Okay.
Right? Is that what you find? You got
Yes.
5 numbers and 5 numbers?
Yes.
Okay, so we know the median is 2. Nathaniel.
I'm so sorry.
It's okay. I started recording also, so I'll send you this link so you can catch the first half of class today. But if you just want to sit down and get ready and kind of catch up with us,
Yeah.
we'll get going.
I got my homework done.
Awesome.
I have the 10 numbers, the median
Excellent.
17 and 60.
Okay, hold on, get that out. We'll go over it while Tanner and I finish this up. Okay, so median is 2. So then
I think
that's
the lower, medium,
lower quartile.
medium,
The LQ.
LQR. No,
Just LQ
is 1.
1. Okay.
And then HQ, headquarter.
Oops, upper quartile. UQ.
Oh, my bad.
Yeah, it's okay.
I put high quartile.
Yeah, upper. Okay.
It's 4.
Yep. Okay. And then what's the IQR, the interquartile range?
IQR.
3.
3.
Yep. How'd you find that?
I subtracted 1 from 4.
Yep. Good. Okay, it's 3. Then what do we do with that 3?
You times it by 1.5.
1.5, so that would be 4.5. And what do we do with that number?
So you subtract it from the 1.
We're gonna get a negative number.
So can we just put 0 down?
Yeah, we don't have negative TV sets. Okay.
So 0. And then we add it to the
upper quartile. So 4 plus 4.5.
It's 7.5.
8.5. 4 plus 4.5. 8.5. Okay. So do we have any outliers?
No, we do not have no ideas.
We have 1 television, which is not a negative, and we have 5 televisions at the upper, which is not more than 8.5. So there's no outliers. So we can work with this data set as it is.
Yeah.
Find the mean, add them all together, divide by 10. Find the mode, right? Yeah, you know how to do that, right?
So mode would be 2 and 1.
2 and 1.
Or 1 and 2.
2 and 1 or 1 and 2. Good. You put them in order. Okay.
Range.
The range
would be 4. But when we did this way, we got 3.
Yeah, the interquartile range is 3. And the overall range is 4. Yep.
And then median.
The median is still 2, right? Because we didn't throw anything out.
Yes.
Okay.
2.
All right. And our mean
is
1 plus 1 plus 1
is 3
plus 2
is so then there's 9 with the 1s and 2s.
Okay.
And then 12, 16, 25.
Let's see. I get 1 and 1 is 3, and 2 is 5, and 2 is 7, and 2 is 9, and 3 is 12, and 4 is 16, and 4 is 20, and 5 is 25. Did I count that right? 1 plus 1 plus 1 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 3 is 12, plus 4 is 16, plus 4 is 20, plus 5 is 25. Okay, 25 divided by 10?
2.5.
2.5. All right. So median is 2, mode is 1 and 2, range is 2.5, or excuse me, range is 4, and mean is 2.5. What is our median mode? Our median mode and mean are all hanging out with the 2's, aren't they? That should make sense.
Yeah.
The mean is 2.5, the median's 2, the mode is 1 and 2, so
Wait,
it would
the
make
median
sense. The median is 2.
Yeah, you said median was 2.5.
I'm sorry, median's 2,
Mode's 2.5.
2 and 1, and the mean is 2.5. And they're all
Yeah.
hanging out with some sort of 2 involved, which should make sense because if we look at our data set, there's a lot of 1s and 2s. So the 3, 4, and 5 pulled our average up a little bit, which is fine because there wasn't any outliers.
Yeah.
But what is that? Oh, somebody must be trying to IM me or something.
No, that was me.
Oh, that was you?
Yeah.
No. I was like, is that me beeping? You beeping? All right. Okay. So, Nathaniel.
Yeah.
You had a data set that you had to manipulate. All right.
Yes, I
What
did.
were
Yes.
the people that you randomly surveyed? What were their ages?
Well, I did a lot of surveying at home because I didn't do a lot here.
Okay.
So I'm going to have a lot of outline needs.
Oh, maybes. Okay.
My grandfather is 68.
68.
My grandmother is 67.
Okay.
My other grandmother is 68.
Okay.
My dad is 40.
Okay.
My mother is 43.
Okay.
Miss S is 27.
Okay.
Let me look at my list here. I have more. Oh, my girlfriend is 18.
Okay.
Tanner is 17.
Okay.
I am 17.
Okay.
My dad's girlfriend is 32, and I think that's everybody.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You are correct.
And my
Okay.
average came out to 38.7.
Okay. How'd you find the average?
I added up every single age and divided it by 10.
Okay. Good job.
He has a
And what
much
did you?
bigger average than I do,
I know because he randomly sampled family and friends.
which are older.
Right. So what was it? 38 point.
38.7.
38.7.
I added all the ages up together, and I got
Okay.
387.
Good. All right. Okay. Then what?
And then the medians, both of them, were 17 and 68. Because they are the only recurring numbers.
Oh, you're talking about mode.
Oh, sorry, yeah.
Yeah. Okay.
The mode.
The mode is 17 and 68. Let's see. You had 2 68s and 2 17s.
Oops, I
That
didn't
is
put
correct.
I didn't put them in order, though.
Oops.
Oops.
That's how you have to find your median.
Yeah.
All right.
Didn't put them in
Housekeeping. Yeah.
order. Yeah.
So we got 17, 17,
18,
18.
27, 32, 40, 41, or 43, and 67, 68, and 68.
Good job. So you did kind of have them in order.
I just didn't write them in order.
I know.
didn't-
All right. So what's the middle? 1, 2, 3, 4, 5. You got to come into the middle.
17, 17, 18, 27, 32,
Mm-hmm.
and then 40.
Okay.
So 32, 40 added together is 72,
Mm-hmm.
divided 36.
Yep. 36 is your median.
Yay.
Okay. All right. Then what?
Isn't that it?
You have to find range.
That's 17 and then 68
Yeah, 68 minus 17.
is 52,
51.
51.
Okay. So your range is 51. Yep.
So
So your range is 51, median is 36, mode is 17 and 68, and mean is 38.7.
Yeah.
Okay. Now, are you thinking there might be an outlier or more than one?
Yeah, my grandmother.
Okay, 68.
My grandfather.
Mm-hmm.
Most of the mid ages were in the 30s and 40s.
Mm-hmm.
So me and Tanner.
Yep.
And my girlfriend.
Maybe you guys might be outliers. Okay.
And then, yeah, that should be it.
All right, so that's your guess on outliers. So now we're going to take that data set and Tanner is going to talk us through how we're going to figure out whether there's any outliers or not, because that's what he and I were just doing.
So first put in order.
Okay, so you're,
17, 18, 27, 32, 41,
40.
hold on, he's trying to get ready.
Please, kid.
I know, come on, kid. You're quick.
Come on, horse jack.
All right.
Why, thank you.
Oh, shoot, my pens, I've got to get new pens. They are just not working.
So two
Okay, there you go.
17s.
17, 17, 18, 27, 32, 40,
43,
43, 67.
67, 68, and 68.
Mm.
Much different age than mine. But
Yeah, because
It's interesting though. I'm glad you guys did this. Like you just, you do it. It's okay because it's kind of fun to look at Tanner did the school and you did outside of the school. It's all cool. All right. So what's the first step we got to do, Tanner? Because we're going to determine whether he's thinking that maybe 17 and 68 are outliers.
maybe.
Maybe.
So
Okay.
you count in 5 numbers. So there's 5 numbers
32.
on each,
And
on the lower quartile and the upper quartile.
Right. So there's a lower quartile or a lower end of your graph, which is half of your data to the left. And there's an upper quartile. There'll be an upper quartile or an upper half of your graph, which is the 50% of the data to the right. So in this case, 17, 17, 18, 27, 32 are in the lower half, and 40, 43, 67, 68, 68 are in the upper half. And within that lower half, there's called a lower quartile. And what is that,
Lower
Tanner?
quartile is the middle of your
Lower half?
half, yes.
Mm-hmm. And in this case, it's the median, the middle. So it's 18, right? It's the median, 17, 17, 18, 27, 32. 18 is right in the middle of the lower half. And then what is the upper quartile?
The upper quartile will be 67.
67. Okay. So the LQ is 18 and the UQ is 67. Then what do we do with that, Tanner?
Then you find the interquartile range.
Which is 5 numbers in the middle.
No. Good. That's really smart that you were thinking about, interquartile. But actually, I like that thinking there. It's a range.
The range of your UQ, your upper quartile.
40 to 68.
No, it's what your interquartile median.
So it's the range between the medians. So the 67 minus
and
the 18.
51.
67 minus 18 is
49.
49. Okay. So 49 is your interquartile range. So I'm glad your brain was kind of thinking like you were looking at, if I go lower half, upper half, it must be interquartile, must be the middle. It's the range between the lower quartile and the upper quartile. So that 18 and 67. That's called the IQR. So why do we need the IQR, Tanner?
Because then you times that by 1.5.
All right. So 49 times 1.5. Shall we cheat and
you should
be fast with our calculator here? 73.5.
I couldn't.
Okay.
You could do that mentally too.
Yeah. You take half of 49 and add it. You're right. All right. Now, what do we do with that 73.5, Tanner?
Well, you subtract 18 from it.
No, actually, you subtract it from 18.
So it's going to be negative.
Yeah.
Wow.
So you can just put down 0 since you can't be negative
you
age.
can't have negative age. Okay, even when you're dead, that's not negative. Okay, I guess it's before you're born.
It's a dirty
All right.
And then you add it to the 67.
You add it to the upper quartile. So 67 plus 73.5.
Oh. Well,
will be 100
130 something.
140.5. Okay. Then what do you do with those two numbers? You have 0 or a negative number and 140.5.
So then you look at your number plot and see if there's any numbers that are less than 0, which you can't be. And the likelihood of you living 140 years, pretty slim. So you basically see if there's any numbers that are less than 0 or greater than 140.
Hey man, Noah did it. Noah lived to 940.
So you don't have any outliers in your data set.
What?
Yeah. You don't. I mean, even though there's a big range which you want to report, because there's a bit of kind of even distribution between ages, nobody is substantially
Older.
older enough or younger enough than the middle. So
Hey, wait, there is somebody younger enough,
you,
but not in my data set.
yeah, not in your data set.
Unborn baby sibling.
So
But yes, I had 2 outliers.
Who?
It was Steinbach and JJ.
Oh,
You didn't hear my plot?
I put your number in there, JJ. It's just that it was 11 numbers.
Did you hear my plot? What I had?
Sure, yeah.
I had 12, 12, 14, 14, 14, 16, 17, 17, 27, 48.
Who was all 14?
I don't know. I just went around and asked a bunch of. There's this big group of kids. I was like, can you guys just give me your age?
that's awesome.
Like, for what? I go, I'm doing some data research for school for JJ.
Yeah.
Like, okay.
All right.
Yeah.
This new student looked at me like, what the heck do you
What
want?
the heck? Yeah.
So, JJ,
All right.
I have
Yeah.
something related to math.
Mm-hmm.
Most likely, I'm going to be coming in during half of the period because of the way that day class is and our schedule is now.
Okay.
I can't help that until I can get something figured out.
Okay.
Hopefully.
So I emailed Lowry to try to figure that out too, and so I'll hear from him. But my first suggestion, or what I want to brainstorm with, is that I always record the class every day,
Yeah.
and I will post it to YouTube, and I'll put it on Yammer. Both they'll send you the links. And during lab, you could listen to the first half a class that you missed,
Mm-hmm.
and then you could work on your homework the rest of lab. Would that work for you?
Yeah, that would work.
Okay.
Ideally, that would work.
Ideally.
Ideally.
What are you thinking?
That should work until I get rid of this class, sadly, because I do love the subject matter that's being discussed.
What class is it?
Mythology. We're going over Norse mythology.
So you think you're not going to have this class anymore?
Sadly, no.
Why?
English 101.
Oh, because then you have to go to Clark. Okay.
I have
and
2
then
classes there.
And do you know what your schedule is at Clark?
Yeah, Psych 200 Mondays and Wednesdays, 6 to 8:20.
6 a.m.?
Oh, at night.
Yeah.
Okay.
And then I have English 101. I'm on a wait list, but it's from 5:30 to 7:50 on Tuesdays, Thursdays.
Oh, you're a night student now.
Yeah.
You know what? That might work for you, Baker.
Maybe.
I think you might be a typical
you're-
night student kind of guy.
I love staying up late.
Yep. And that's okay. There are a lot of students that
Then
like
don't you
to take classes at
so
night,
then you
and they
can
do much better at night
Then you can sleep in.
No, I can't.
Why?
because you got to be here.
I have to be.
No, you don't have a first period here.
I might.
Yeah.
They're gonna put me in a first period here.
Oh, geez.
I was gonna say.
You're gonna have long days, dude.
I was gonna say
I know.
push.
Welcome to the college life and the real life, man.
Oh my gosh. If I can go a little bit off topic just for a second.
Okay.
My Psych 200 class deals with the life of the human being from conception until death. It's like the entire outline.
Human development.
Yes.
Yeah, it's gonna be fun. You're gonna love it. My bachelor's degree is in human development. So if ever you wanna discuss,
Yeah.
Human development.
The only time I have it is during math.
and I took it a long time ago, so you could give me some new
You
information.
write my paper.
But you're gonna learn some theorists, some classic theorists about human development and Piaget and Erickson. You're gonna all of a sudden understand why kids think the way they think.
I'm looking forward to
Sometimes
that.
you will like it.
Because then
Yeah.
I can just look at a teenager and be like,
So why do you think I got a tattoo?
well, first of all, my personal opinion on that's going to be a little bit biased, but I think you got a tattoo for a small bit for attention. Also, I mean, I can go farther, but it's not for the look of it, for the way that it shows up on your skin,
Hmm.
the way that it gives you personal satisfaction. Also, things like that. I can give you a more thorough answer after this class. I can give you a more educated.
Yeah, all right. Let's talk about homework before class gets out. So I want you to do this again, but not with ages. What would you decide what you would like to know, like data you'd like to collect from asking people? Would you like to know how many
What's
phones they've owned in their lifetime? or how many
Cell phones or landlines?
or how many that's a good that you'd have to clarify, or something like, what would you like to know? Like, think about this, like
How many times have you moved?
Okay, how many times have you moved in your life?
Or how many different schools have you been to?
Or how many, there we go. Ooh, I like that one. All right, so are you going to ask how many different schools? Okay, so 10, so you'll have to ask 10 random people. Now, are you going to decide in your sample, is it going to be just students, or is it going to be anybody that you run into? You want to know how many schools they've been to in their lifetime?
I think just students.
Just students?
Nope, I'm gonna run into anyone.
Okay, all right.
Go back and ask me. See.
Okay. Okay, so you want to know, you're going to want to know, so you're going to do the same thing, Nathaniel, but you're going to change your sample, and it's going to be, you're going to be anyone you run into, you're going to ask them how many schools they've been to. And your criteria, your clarifier is, you're a student, how many schools have you been to?
So like, for like Nathaniel.
You can, if you want to do you want to do a different one?
I was going to say for Nathaniel, if I ask him how many schools have you been to, would he count this one, Bate, and Clark in one?
Yeah. Wouldn't that be?
That'd be 3.
That'd be 3 different schools. But have you been to any other schools besides this one?
Oh, yeah.
Yeah.
In kindergarten, I went to a school in California.
Yeah. So there you go. You don't have to name the schools, but that counts, right? Okay, so that's clarifying what a school means.
So, Baker, how many schools have you been to?
5. All right, there's your first data. Okay, you can't ask me. Right?
I know I can't.
Okay, because I'm not a student. Okay, now, Nathaniel, what do you want to ask 10 random people?
I'll do my sister.
I'm
but
thinking.
I can't do my sister. She's not a student yet, but she is a student.
Yep, you can do. That's right. It just has to be. Your clarifier was they had to be students. Didn't say here.
Will you say preschool is a school?
Yeah.
It requires numbers for answers.
So what are you thinking, Baker?
I'm trying to think of a really deep philosophical question that requires numbers for answers.
Okay, I like that.
How many cars have you owned?
That's going to be a low number for a lot of people.
You'll be surprised how many.
If you run into adults, you'd be surprised, and it'd probably be hard for them to figure that out. You know, they'd be like, "Oh my God, since I was a teenager, let's see." Like,
how many cars have you owned?
I'm trying to think about it. Like,
I think.
How many times
2,
have you done
3,
stupid
4, 5,
things in your life?
6, 7.
How many times have you fallen on the sidewalk?
9, 10. I think I'm 13 or 14.
God, wow.
You'll be surprised.
15. I can't even keep track. When you're an adult, it starts to get up there, because when you're a kid, you go through a few like junkers, you know.
Like when my cousin was
younger.
cousin, when she got her first, and she went through a Mustang, then she got a Jeep, and she sold the Jeep, got another Mustang, then got another Jeep, truck, all at the same time. And she sold all those, got a new Mustang, now she has a new truck.
How old is she? 20?
21, 22.
Okay, so what do you think? What's your deep question you're thinking about asking 10 random people, Baker, that you want to know something about?
How many times have you been in love?
Ooh, all right.
Me, Baker?
How many
None.
times have you been in love? Oh, now you got to clarify that. What do you
Would it
mean
be
by-
with your?
Is it in love with anyone?
Or like your parents?
Like you're in love with your parents, or are we talking about
A car?
Relationship.
Okay, so how many times have you been
I've been in love with a car
in
before.
in a relationship?
Are you still recording?
Not yeah.
Oh.
It's all good. Okay.
I'm not going to ask you the question
All
I
right.
was going to ask you.
So make sure that you're careful with
The wording of
the
that.
wording of it, and you clarify it. So, and you clarify it the same way with every person, because if somebody interprets it as, well, I was in love with my pet cat when I was 3,
Yeah.
you know, so you'd have to say, or maybe you might want to ask, how many relationships have you been in?
Yeah.
Maybe that, instead of the love factor, because sometimes people might say, well, I had this one girlfriend, but I didn't love her, right? Or maybe you do want to know, like maybe you want to know that, maybe you want I only want to know when you were in love. You know, I don't know. You have to decide, but make sure you're careful that you don't change that person to person.
Each time.
Because what would that do to your data? Yeah, and it's not gonna be trustworthy, is
It
it?
might be a sensitive question for people.
All right. So I want to know, when you report to me, what question did you ask your person every time?
I don't think I'm going to have an outlier of this. I'll try it.
All right. So you have to do all the analysis on it now. You got to do your range, your mean, median, mode, whether you have an outlier or not. So that means you have to look at your lower quartile, your upper quartile, the interquartile range, multiply it by 1.5, subtract that from your lower quartile, add it to your upper quartile, look at your data. Do I have outliers? If I have outliers, you got to kick the outliers out and do your mean, median, mode, range on again if you have outliers. Okay?
Gosh.
All right.
Hopefully I don't.
Okay. It's no big deal because it'll go so quick. You saw how fast we worked on it now, right? It's fun.
This
Okay.
is
Doing it in lab.
All right. Okay. I'm going to stop the recording.
How much time do you have left?
And